Welcome to the Data Driven Manufacturing Podcast, where we explore how data is transforming the manufacturing world. My name is Rowan Easter Robinson, and I'm an engineer at Track My Machines. I'll be talking in every episode to engineers, business owners, and professors who are leading the way in data-driven manufacturing. Let's get started. So today I'm here with Rupert Blackstone. Thank you so much for coming on the podcast, Rupert.
It's a pleasure, Ron.
Yeah, it's nice. I've come to sunny Stroud. It's a beautiful, beautiful day. Really gorgeous part of the world, and you're quite an interesting character. You work right now running a company called Wattcraft. We'll talk about that in a little bit as well. But you're also part of a board or a group in the IMechE as well. So you've obviously got a lot of interest and passion in engineering. Tell us a little bit about yourself. What got you into engineering right at the start of your interest in this subject?
Well, at the time before choosing my A-levels, I was interested in art subjects as well as engineering, and I had a fairly balanced interest. I got drawn towards the sciences. I like the black and white nature of it. I think in part because when people are marking it, it's quite objective. You know,
it's obvious why you're wrong, and obvious why you're right.
Yeah, so you know where you stand with it. But also I was interested in discovering how things work and also the idea of making things happen and feeling as though I could do something tangible in my work and see outcomes that would benefit society in general, although at the time I was probably not thinking so widely about society, but there was an interest in the subject. And I did sciences and maths at A-level. I then went on to do a degree in mechanical engineering. That was at Manchester University. And in my third year, I specialised in in the modules I could choose. There was a renewable energy module and an environmental engineering module. So it was that time when I first developed an interest in environmental engineering, because I wanted to apply engineering to helping the environment. I at that time, that was in the early 90s, and it was even then known there was a impending environmental crisis, and so I did those modules, and then I came out of my engineering degree in the mid-90s. I was quite particular about looking for environmental engineering work, and there was a recession on at that time, so it wasn't easy to get any kind of engineering work,
Especially in green tech, I guess.
Well, that's it. And so I was being a little perhaps too particular, but I was quite focused on getting environmental engineering work. While I was looking for engineering work, I worked for a nursing agency based in Stockport, but going to nursing homes and hospitals around Manchester and Greater Manchester area, and I wanted to do something meaningful and rewarding while I was looking for engineering work. That ended up being a year, and towards the end of that period, with feedback I'd got from one interview in particular for a company, I saw it's going to help me to get an additional qualification to give me more chance in that quite at the time quite a niche job market. So I went to do a master's in renewable energy systems technology for a year at Loughborough University, and then after that I got a job at Wessex Water in Bath in engineering services. That was my first graduate engineering job. And
was that all about managing the water systems and managing water supply?
Yeah, it was design of water and wastewater treatment systems, and I worked on both sides, both water and wastewater sewage, and I went on the IMEC monitored professional development scheme towards chartership, which meant I had to have a range of different types of training covering not only doing work in the design office but also experience of manufacturing. I did a placement at Weir Pumps in Glasgow. Did some machine shop in Bristol, and I worked on site at Avonmouth sewage treatment works and Western Supermare sewage treatment works.
As far north and as far south almost as you can get.
Well, Glasgow, around Bristol, and I was, whilst I was getting general engineering experience in water and wastewater treatment, my focus was on looking at renewable energy. I mean, they were interested in my renewable energy qualification, and the area of renewable energy that I looked at Wessex Water was looking at different ways of getting energy out of sewage sludge. At Avonmouth sewage treatment works, there were anaerobic digesters already there with Caterpillar gas engines generating.
Was that quite a new thing there, trying to extract, get gas out of sewage sludge and then use that to, I guess, heat something or generate electricity?
Well, I think the technology's been around for a while, probably since at least the 1970s. That at the time they were upgrading the engines. They'd been installed a few years and hadn't been. I can't honestly remember when they were first installed.
So it wasn't new tech.
New tech.
Anaerobic digestion is something that is big. There's a company in Sheffield called Future Greens, and they're trying to work on using spent grain from breweries, and especially in Brewdog, Thornbridge Brewery.
Yes, yeah.
And they're trying to build out anaerobic digesters in like a modular way now and trying to keep the cost down. But I didn't realize the technology's been around for such a long time.
Yeah.
I guess all these ideas, especially like solar panels as well, the idea of a solar panel has been around since the 60s or the 70s from like the LED, because it's basically an LED, kind of the way it works electrically.
And wind energy, wind turbines.
Yeah. But I guess the fact is they just were not applicable at a mass scale. Like
that was the difference back then.
Yeah.
I mean, the technology was there, but it wasn't being deployed to the extent it is.
And it's something we're going to cover a bit today, is talking about how companies, especially SMEs in manufacturing, how they can try and get as much of their energy usage from renewables, from more sustainable sources, why that's important, why they should think about their impact on the environment, why they can have kind of an outsized impact compared to other companies who are just doing warehousing, maybe, for example, or in recruitment or whatever. Manufacturing is a big impact on the environment, and that's obviously something you care a lot about. So that's what I'm really interested in talking about today. As well as the kind of the phrase ESG, we will talk about as well, which I think is it's kind of gone through a surge in use and popularity, or unpopularity as the case may be. And I think we kind of leveled out, and a lot of the hype around that idea is maybe subsided, and now companies are realizing it's something they should just do, or they could just do. It's not just about trying to tick a box for an investor, it's something you do because you care.
Sure.
So today I think this is all about engineering with a conscience, I guess. And that's obviously something you've kind of tried to embody, I guess, even from working in a nursing home and doing your masters. I think that sounds like it's a thread that's always kind of followed you around, and you've not been able to either shake it, or it's just been a passion that's driven you. Yeah,
well, I think the word you use is purpose, and that's the big part of it. I just find it motivational if I understand why I'm doing what I'm doing. Really, I mean, that's because any work has areas of grind when you just got to just push through it. But if you have a purpose that you believe in,
there's a big
why. Makes it easier.
It acts like a North Star guiding you and keeping you on that road, even though it's a tough road and it's a painful road.
That's right.
So it's really interesting, and for you, it's obviously it's environmental concern. Where does that come from? Do you think? Do you mean you're like spending time out in nature, in forests, like touching grass? Or like?
Well, yeah. When I grew up around here in Stroud, there's some beautiful nature here. Maybe that is a big part of it. But it's a good question. I mean, other than that, I don't really know, but I do appreciate the nature here. I mean, I grew up here, but I moved away and lived in cities for 20 years and came back about 10 years ago. I felt a reawakening in a way, being more connected with nature again, because I think living in cities, although there were, the nice parts, it wasn't quite the same connection, and it's easy to forget that.
At the end of the day, though, I guess, regardless of where you live, whether it's a city or a rural area, you're going to be affected by today's kind of, it seems like a lack of awareness, a lack of interest in what our impact is as humans on the planet, whether you live in a city or in
that's
in
right.
a
And
countryside.
actually, people often have a far lower environmental footprint in a city than they do in the countryside. I mean,
Because you're not driving around.
not driving around,
place.
public transport, places. Yeah, that's right, exactly. So it can be more environmentally benign, and you can get more exercise because people take public transport. Whereas a lot of times in countryside, people get in their car, and you wouldn't believe the distances people drive. A few hundred meters.
Yeah, let's talk about people's impact then. First of all, we met at a talk 3 or 4 weeks ago, organised by the Northwest Aerospace Alliance, which was all about manufacturers measuring their emissions or their impact on the environment in terms of greenhouse gas emissions. Not anything else, because manufacturers obviously can have impacts in other ways, like in terms of chemical pollution, in terms of other kinds of pollution. But that talk was laser focused on greenhouse gas emissions and the protocol that's been rolled out in the EU, and I'm sure manufacturers in the UK care about it as well. We will talk about how to measure it, how to try and reduce it, and why you should, as a manufacturer, be interested in this stuff. But before we go into that, you guys started with like a quiz. It was all about people's guessing what people's CO2 equivalent impact was on like a cycle to work or a drive to work. And there's some quite interesting numbers there. It's all about if you cycle to work, depending on what you've eaten, you have a certain impact, and whether you leave the lights on, or whether you send an email or a text. And quite a lot of those are out of a certain book, aren't they? There's like a book about bananas.
Yes, how bad are bananas?
Yeah, so how bad are bananas?
Not bad. No, that's
that's the result.
Not as bad as yes.
Yeah,
That's
bananas
the conclusion
aren't
of the book.
Well, I'd have to read
they
it
come
now.
from a long way. Well, that's the thing. People think because they come from exotic fruits, in fact, coming from a faraway place with all the transportation, that they're going to have a big impact. But it's not necessarily as impactful as
intensive farming right on your doorstep.
Exactly. Yeah.
And it's about trying to find I guess the big numbers. If you do, is it called a life cycle analysis? Is that the word, when you're trying to do an assessment of, I'm making these notebooks, what's the impact of this notebook production on the planet? Is it the paper? Is it this fake leather? Is it this thing? What's the big 80-20 rule? What's the big Pareto, like the big impact? And with bananas, it's not the transport. With almonds, it's the fact you need loads of water, I guess.
Yes,
and it can be quite unintuitive what the actual impact is.
It can be, yeah, and it makes a difference. I mean, if we're used to getting anything any time of year in the supermarket, but if you look at when you buy watercress, for example, it's going to make a big difference if you buy it in the summer, it's from the UK, than if it's imported during the winter. And life cycle assessment, in that, if we're thinking about the industrial manufacturing context, there are the embodied greenhouse gas emissions in the materials and components that are brought into the factory, and then there's the operational energy use. And so if you've got a static system such as a tank and pipe work, then there are the losses through the tank. I mean, if it's not so well insulated, then there's going to be a life cycle, an operational stage of the life cycle impact on the environment. But a lot of the impact will be in the manufacture of those systems. Whereas if it's a pump, then most of the impact will be in the operation of the pump, the energy it uses, and the environmental impact of that in terms of emissions associated with electricity generation and supply. So when you're looking at the life cycle, you're considering where do the materials come from, how they extracted, what's the environmental impact in the processing of those materials to turn into a manufactured product, what are the emissions associated with the operation of that product, and then at the end of its life cycle, what are the emissions associated with its disposal, and well, not just emissions, the whole environmental impact, because if it was a battery, for example, there's some toxic chemicals often used in battery manufacture that can be hazardous in disposal and have an impact if they're not treated with care. So that has to be taken into account as well. And it starts off with very scientifically in terms of working out life cycle impact, because you're analysing all the data associated with the material and energy flows throughout the life cycle. And then that data on material and energy flows is translated into environmental impact. I mean, if it's a material flow, it could be depletion of finite resources. And then if it's pollution, air pollution, water pollution, then there are impacts associated with that. But beyond when you've worked out what the impacts are in terms of the impact category, then there's a question of what's more important, and that's where it becomes less scientific, more subjective, and that's where communication is important. For example, if you consider diesel versus petrol internal combustion engines, diesel engines are more efficient than petrol engines generally, and so there's less carbon dioxide production compared to petrol for diesel, and therefore less impact on global warming. But then there's more particulate emission with diesel and petrol, which is bad for respiratory illness, and particularly in an urban environment.
Yeah, hence the clean air zone policies, which have obviously caused a bit of uproar for some people, but clearly are working in London, even though they're causing a lot of upheaval in the way people, cars people can use.
Yeah,
and they've been hugely successful in improving the quality of the air in London.
They have, and then when you're at that stage, you think, well, what's more important? Is it more important to think of local people's health or remote people's impact from global warming, because of rising sea levels and the Pacific Islands are going to affect people thousands of miles away? The respiratory illness is going to affect people right here, and that's why I think when we think of sustainability, we not only need to think of your own business and its impact, but how that relates to the global picture because of all that interconnectivity. And if you ignore that interconnectivity, it can come back to bite you, because then you can get breakdown in supply chains, which are going to affect your business. So even though you might not be able to see the effect on your business today, if you don't think in terms of acting more sustainably along with other businesses, then there's a danger that systems can break down, which we're all dependent on.
Yeah. So let's talk about engineering with a conscience for SMEs in manufacturing specifically. I guess a lot of what we're talking about in terms of thinking about working more sustainably fits under the S in ESG. Now, ESG, it's a term that I've heard a lot when you go on the Vanguard investment portal or whatever. There's like ESG funds, and it's a big phrase if you follow like finance blogs, for example. There's a lot of big corporations that buy carbon offsets, or they're interested in a diverse board. What does ESG mean for people a bit more on the ground here in the UK, for SMEs in manufacturing?
Well, for SMEs in manufacturing, I'd say there are 2 points there.
What is ESG? First of all, actually, what does it mean? What does it stand for?
Environmental, social, and governance.
Yeah. So there's 3 different aspects to it.
Yes. Yeah. And I mean, when we met, I was working on the banner of ESG3, which is with my associates, Roger Singleton and Christine Fair. Christine's a specialist in ESG assessment. Personally, I have a broad understanding of ESG, but my focus is on the environment side.
The E side.
The E side.
Yeah, which at the end of the day is probably the most important for manufacturers, because they have an outsized impact, probably.
Arguably, yes. I mean, I wouldn't like to say for sure. I mean, the social side is important, and sometimes they're interlinked. But yes, I mean, I think that on the social side, I mean, it covers modern slavery and diversity and inclusion and general employee welfare. So they're all important through the supply chain for global social welfare. But on the environment side, there are often more short-term tangible benefits, because if it's energy, for example, I mean, there are energy savings which can give you cost savings. However, having said that, if you don't look after your staff, and they leave, or recruitment's expensive, so that's a cost to a business as well. So the social side is important, and the governance side. Well, I mean, you need some coordination. You need buy-in at the top to support the implementation of the measures on the environment and social side. And the thing is about sustainability is it's not just a technical thing. It is important for everyone to play their part in it, in the company, and that includes procurement people, procuring products in the supply chain that are sustainable and fit with the company's sustainability objectives, human resources in training people in the company to get the right skills to operate more sustainably and to recruit people with the right skills as well. So everyone has their part to play, and those three areas do have to work together, really, for them all to work.
And you've got a significant role at the IMechE as well, trying to, I guess, have a discussion around it and how that applies to the UK industry as a whole.
Yeah, I mean, I met Roger, my associate I've mentioned, on the Energy Environment Sustainability Group Committee, which I chaired for 10 years. I've just handed over the chairship. The great thing about that group is it's got people from different sectors relating to the environment: energy, transport, waste, water, manufacturing. And that means in our discussions, we can think about a systems level integrated approach to sustainability.
Of like the whole country, you mean?
Across the whole world.
Across the whole, right, okay.
Oh, well, I mean, yeah. I mean, well, we think about the whole world. I mean, we're not saying we have across the world. We have people, members overseas.
Oh, wow, yeah. I thought the IMechE was just about the UK and Ireland, or... Yeah, that's interesting.
Well, it is predominantly. It's very. I mean, but I mean, there are outposts around.
You're making it sound like a nefarious group of people coming together and trying to figure out how to make the world a better place.
Well,
we don't want that.
It is. It's an interconnected world. I mean, on our board, we've got a member from Sri Lanka who's based. I mean, he doesn't come over for meetings. He joins remotely. But we're open to
he'd have to take a boat. He'd have to row, wouldn't he, if he was gonna.
It'd take a while.
Yeah,
it's
fascinating. So on I guess I don't know how much you can talk about what you discussed in the board with the IMechE, talking about the sustainability of manufacturing, transport, wastewater. What kind of stuff? What kind of things do you discuss that you think are really relevant for manufacturers, maybe, to understand?
Well, one of the approaches we really emphasise is the energy hierarchy, which is prioritising the reduction of energy demand before considering energy efficiency measures and then renewable energy. And that's really important. I mean, one, from a business perspective, it's often a lot cheaper to reduce your energy consumption than to put in a renewable energy generation. But also, if you are thinking there's the potential for renewable energy generation on your site, for example, solar photovoltaics on the roof or a wind turbine on the site, then it's you want to have the right type of renewable energy and one that suits your demand profile, because the cost of importing electricity is much higher than the value of exporting electricity. So you want to minimize your export.
You want to just use it, basically. If you're producing electricity on site, you want to use it. You don't want to be giving it, selling it back to the grid, because you won't get that much for it, basically.
No, that's right. And that's where your business is important in measuring that use. Because if you can understand not only the overall use as it is, but where you can make changes to the use, and that's not only through reducing the overall level of use on an annual basis, but also potentially the timing of use. Because if you got a generation profile for solar, which is peaking in the summer and peaking in the middle of the day, or you've got a wind generation profile based on forecasting of wind resource, then you can adjust your loads accordingly, because within the manufacturing environment, some machines might not be so time critical as others, so that you can have the load shifting to better suit the demand profile and maximize the use of that renewable energy generation.
It's a really interesting concept. I think I went to the AMRC Northwest has also done some work on that as well, which is where we met the AMRC at the bit in the building. And they were looking at using, just simply solar forecasts. So what the expected solar, I guess the solar energy on a given day based on the clouds or whatever, will allow you to run and tell you which times are the best to run your machinery.
Yeah.
And which combination of machines will keep you under the minimum level, or keep you just at the point where you're only importing a tiny little bit of energy. And it's a really interesting topic. I'm going to be honest, I don't think no SMEs I know of are at that point yet where they can move their production around based on energy use. But with the rising cost of energy, it might be a really significant factor.
Well, that's right.
10, 15 years from now.
Yeah, I mean that's a good point, because I think it's important to think what's about appropriate technology, because there is a tendency to overcomplicate things sometimes. It's in some companies' interest to go and put in fancy complex systems that measure this, that and the other and process it with AI in the cloud, and then come out with an answer as to what you can do. But if you're constrained as to what you can do because of your process pattern and the way things are set up, then you don't need to be told what to do, because it can be quite obvious because you've got limited options. So I think what I'd encourage people to do is, before investing in a complex system with demand management, to just consider what's appropriate.
And that's interesting, is the limitations on manufacturing businesses. I mean, you with Wattcraft, your company, you're trying to work with various different organizations, but you're focusing on manufacturing right now, in trying to reduce their energy, in trying to improve every aspect of that energy hierarchy. Number one being reduce energy, and then all the way down to how do we get energy without paying for it from fossil fuels? How do we get energy in other ways, like with wind or solar? But I guess, what's the major things you bump up against with your clients, your manufacturing clients, that their limitations is, well, we can't reduce our energy consumption because 99% of it's that furnace, which we need to get some steel up to 1200 degrees or whatever they do to then go and stick it in a forge. So what do you think of there's some significant limitations to manufacturing businesses trying to reduce that energy consumption first, but there probably are some creative ways that they could do that that maybe not thought about.
Well, you mentioned a good example. I mean, that's the big challenge. The process heat load, particularly high temperature heat loads, are typically expensive to do with renewable energy. I mean, if you look at brewing, for example, of beer, the kettle for boiling the wort uses by far the most energy out of the whole process.
Same in a cup of tea, right? You said the energy impact when we were doing the quiz about the US
Yes,
CO2e.
yeah.
It's just about, you'd think it would be the transport of the tea from India or God knows where, packaged up in a tea bag and then sent through a warehouse to deliver to Tesco. You go and buy it from Tesco. The actual major impact is you turn the kettle on at the last minute making that cup of tea. Because of the energy intensity of the specific heat capacity of water. It's just a simple number, isn't it?
Yeah.
That's what makes the most of the energy. So it's the same thing with a lot of other processes as well.
Yeah, that's right. Yeah. But to boil using renewable energy systems it tends to be very expensive. I mean, if you consider biomass, I mean, there are issues there in built up areas with particulates, with clean air zones, and that's fallen out of favour for a lot of possible companies to an extent. But then if you consider heat pumps, the technology is improving, but the higher the temperature is, the less efficient it is, with the lower coefficient of performance. So for each unit of electricity, you're going to get less heat at a higher temperature. So it's very hard to get those high process temperatures in
without just a big fat element. With
and if you have a big fat, I mean, if it's steam process, then you need big expensive kit that's more space take, and the operational cost is going to be much higher. So that can be prohibitive for a lot of companies. But ultimately, if it's not going to be electricity, then the alternative, I mean, hydrogen is something that is being trialled in manufacturing industry.
For running furnaces, for running
so just
heating up material.
Pilkington Glass in St Helens, where hydrogen. If you look at the energy balance of hydrogen, there's a lot that's lost in the production of hydrogen from the original energy source. If it's produced renewably, say from wind energy, then you've got the loss in the electrolysis to produce the hydrogen. You've got higher losses in compression and distribution than you do with natural gas. And then at the other end, you're going to get losses in the inefficiencies of translating combustion energy into usable energy compared to direct electric heating. But so, I mean, on a national level, that's an issue. You know, if we're going to supply, I mean, it's another subject, but in my view, it doesn't make a whole lot of sense to have a hydrogen network when a lot of the gas in the network is going to be burnt in a boiler in people's houses. It makes more sense, in my view, to dedicate the hydrogen to industrial applications,
because you can manage the process and try and reduce the losses with a concerted effort and investment.
Yeah, you can. Yeah, and also because it's scarce, you want to minimise your use of hydrogen because of the losses in its production. In general terms, it's better to use electricity with that. Well, first of all, heat pumps. Because you get more units of heat than units of electricity in. That would be a priority, but given that they've got their limitations in terms of high temperatures, then direct electric heating would be the next choice. But then for certain process heat loads, several hundred degrees, then hydrogen is a potential good option.
And there's a question of there's a potential question of where the hydrogen comes from, because if you use the electricity to the electrolysis, there's green hydrogen and there's not green hydrogen, right?
That's it.
And we're shipping in potentially green hydrogen from Saudi Arabia, from a Gulf state. I think it's starting to produce. They're producing a big plant to make green hydrogen. They're going to ship it over to the UK, and that's still going to be using a big ship that's run on bunker oil.
Right.
That's another fascinating topic. Is there's kind of like there seems to be a lot of ideas that sound great on the surface, but when you dig into them, there's actually they're kind of just a much of a muchness compared to other options when they sound like these catch-all solutions. We'll just use hydrogen, but actually it's going to get shipped from a Gulf state. It doesn't solve the underlying problem of we're trying to reduce our impact on the environment, not just change our impact on the environment.
Yeah, that's right. And then there's a question of energy security as well, because I mean, one of the good things about renewable energy generation here in the UK is that we're not dependent on other countries to supply our energy. As you know, when Russia invaded Ukraine, we felt the impact of an interconnected energy market and gas supply, and prices went right up. But with renewable energy, we've got more control over it, and it would make sense to minimise the import of hydrogen across the sea.
Okay. A simple question. If SMEs, if they've done everything they can to try and reduce their energy demand, let's say they've explored different options. Okay, they've got a furnace, but they can't change that. That's like a minimum fixed demand. They've got LEDs. They've done all the initiatives, I guess, around the offices. Should every SME manufacturing with a roof that's a reasonable size stick solar panels on it? Is it going to pay it off? And is it pretty much going to pay it off for most buildings in the UK, or is it quite still really heavily dependent on your geography, cost of electricity, the orientation of your building? Basically, should most SMEs think about solar panels today?
Well, I'd say that most should think about it. Shading's an issue. So if you've got a shaded roof, that's no good. If it's an asbestos roof, that's probably going to be prohibitively expensive. So it's got to be reasonably structurally sound and of the right material, either flat or ideally south-facing, or east and west-facing is okay. If it's north-facing, can be okay if it's a shallow gradient. Really, you're not going to see a great payback if you're not using over half the electricity.
So that's the major thing. As long as you've got a decent roof that's probably east, west, south facing, if you've got big energy demands, you'll get a payback.
Yeah.
If you've not got big energy demands because you're just an office block, then you're not going to get a big payback. That's interesting, because I guess with domestic supply, if you've got a domestic solar and you're not going to use all that solar, then selling it back doesn't make sense. You don't get payback either. But if you've got big machine tools and you've got big fat inverter, you've got a whole bank of solar panels running mid-July, you could probably run 3/4 of those CNC machines off the big bank of solar panels, which is amazing, really, isn't it?
Yeah, I mean, it makes total sense to do in those circumstances.
There's a great company called GW Martin who they're being recognised quite a lot, I think, right now for the work they're doing, but they've in apprenticeships and investing in people as well. But they've done a recent big investment in solar panels, and Stuart, the guy who runs GW, was saying, kind of, I think for a month and a half at least in summer, they are running the whole shop off solar, which it's amazing that I know the sun is powerful, but running literally, I think they've got something like 35, 40 CNCs, which are, some of them are hungry beasts, big spindles, high-speed machining, running the coolant pumps, running the hydraulics. It's absolutely amazing. That big electromechanical thing can be run off, those solar panels above them. And that's a real success story, is GW Martin. I'd love to talk to Stuart more and maybe get him on the podcast or something if you'd be happy to do it. And I just think that a lot of SMEs can use that as a bit of a case study, an example of what they can do. But it sounds like a bit of an easy switch. Is just do your solar panels and that's it. You've done your E in ESG. Is that right?
Well, no, I mean, you
bit of a provocative question.
Well, the demand reduction, go back to that being the priority.
But if you've got an old CNC machine, it's doing good work, you can't swap it out without making a big investment,
No, but I think there's a case of putting policy in place for
switching
reviewing.
them off.
Well, no, I was thinking because you made a point. I mean, you're right. With a lot of machinery, it could be millions of pounds for a machine, and you're not just going to switch machine because it's going to use less energy. Yeah,
we're talking probably between 60 and 200k from a new machine.
Okay.
Depending on the style and the type and stuff, obviously.
Okay.
But so it's not massive, But it is still, for some subcontractors, it's definitely, the machine works. It might be using a bit more energy, maybe 5 kilowatt hours an extra per hour or day, whatever. But it's still not,
But I mean, whatever it costs, the point is that it's not just the energy consumption that's going to determine whether to change the machine or not. I mean, more often than not, at the end of its life, I think, or if it's stopped being useful, then there'll be a decision to replace it. And when I say policy, it's good to have a policy in place. So when you make the decision to replace the machine, then it should be done with the energy and emissions in mind, because we've got the government commitment to reducing greenhouse gas emissions to net zero by 2050. Seems a long time ago.
Long time ago. Oh no,
to the future.
Have we already done it? That was quick. But yeah, we've been talking that long, Rupert.
Just been talking about it.
Oh God, we need to this will never come out if it's still 2050.
So it seems a long time off, but it's 25 years. I mean, machines can last that long.
Potentially. But if they were built a long time ago, they will last that long. If they were built 10 years ago, they probably won't.
No, I mean, but the point is, we're getting into the range of machine life now. I mean, a wind turbine, for example, is it's guaranteed for over 20 years, and so same with solar panels. So we're getting into that zone where investment decisions now
will have that number in mind.
Well, yeah, and the thing is, for example, if you have a machine which has a thermal element to it, and it's currently running off gas. I mean, it could be an extrusion machine, for example, it's extruding plastic. Then you've got a choice. If you're replacing it, do you go with a gas or electric one, if that's a choice? And so having a policy in place saying, well, we'll not just choose a machine based on cost at the moment.
It needs to fit these criteria.
Yeah, so that's what
all electric.
Yeah,
no gas. For example.
Well, that's right, because you send yourself down a cul-de-sac with gas, because you can have that for years.
So so a policy of solar panels, so reducing energy consumption, solar panels, and new machine procurement policy will start to help companies.
Sure, yeah, that will all help. And the other point is, because we were talking about process heat, is heat recovery. So whilst you might not be able to switch right away to renewable heat, if it's process heat load, that could potentially be prohibitively expensive right now for a lot of SMEs. There might be the potential for heat recovery to use in other processes. So if you've got a high temperature part of the process and you can recover the heat to heat tanks, I mean, that happens as standard in the brewing industry. With the kettle, you recover heat to heat the water tanks. But I mean, there are other opportunities in other types of industry where you can do that, and then also just to think about your different grades of heat, different temperatures of heat requirements. So, for example, if you've got treatment tanks and they operate at different temperatures, it might be that the higher temperature ones can't reasonably be supplied by heat pumps, but maybe the lower ones can. You can treat them differently in that way.
So there's some consultancy needed to be done probably around this. Someone who knows and has experience in different heat levels, different temperature differences that you need to achieve. Some can be heat pumps, some can be gas, some can be hydrogen, or if it's a big enough process, it's worth doing.
Yeah, that's
interesting.
Right. And then also, talk about the manufacturing process, but it's also the space around what the space heating and lighting. Zoning is something that can be done, because rather than heat the whole space all the time, there might be different shifts in different parts of the factory, or
you get like a little bar radiator things that
and that's a good thing generally. That's because rather than, I mean, you get those the hot air blowers which fill the space, but radiant heating can be more targeted and end up using.
Can be cold if you're out of that like cone of radiation.
Well, that's the downside to it. But you can have what you can do is have a low, not just have no ambient heating, but you can have a lower level of ambient heating throughout the space, and then task space heating to raise it to a comfort temperature for someone who's stationary at that.
So you can target it and try and be a bit more specialised. You mentioned net zero 2050. How far off are we? Are we on target?
No, we're not. No, we're a long way off.
How far off?
I couldn't say off the top of my head, but what I would say is that if we look at energy consumption split in this country between electricity, heat and transport, heat and transport are so far behind electricity in terms of renewable energy generation. There's a government target currently to be net zero in renewable electricity by 2035, and we're not even anywhere near on target with that. I mean, to do that, we'd need to have probably more than double the amount of renewable energy generation installed between now and 2035 than has been installed since the 1970s.
Wow, yeah, so 55 years of...
Yeah, and that's not really taking full account of increased electrification of transport and heat.
Because we rely so much on natural gas still.
Yeah,
I guess oil, people living in the sticks out in the countryside have got oil like kerosene burners or however they use. There are a lot of people on oil. A lot of people on
oil. That's right. So we're not even meeting our electricity targets, and well, the one set for 2035 at least. But transport and heat are a long way behind.
And then we've got loads of diesel trains, I guess, and loads of people still on petrol and diesel cars. I think I went to an event. I can't remember where it was. There was a guy who was the first presenter for Top Gear. I can't remember his name. Before Jeremy Clarkson and James May and Richard Hammond. I can't remember his name, but he was doing a talk, and he's still doing a lot of work on he's trying to get people to drive electric cars. Basically, he was one of the first proponents of electric cars in the UK. For 25 years, 20 years, he's been testing every electric car that's come out on the road. He's tested them, and it was a room full of engineers generally in machining, subcon, and in aerospace, OEMs, and then salespeople. And he said, put your hands up who's got an electric car, and it was about 10%, 5-10% put their hands up. And it's like, clearly, even people who are technically interested, engineers who are interested in engineering, are not taking the plunge in a new piece of tech like an electric car.
Well, they're not, but then on the other hand, it's not always a straightforward environmental decision, because it can be around half the life cycle greenhouse gas emissions of an electric car in the manufacture of the car.
Yeah, because they're so complicated, heavy. Yeah. The chemicals from that you need to produce them come from unbelievably obscure places with really potentially bad employment practices and stuff. There's loads around the production of an electric car that is just nothing. There's nowhere near the complexity in a standard internal combustion engine. No, and they've been perfected really over 100 years, haven't they? They're so efficient right now. So
well, that's right. And the thing is, if you've got an old petrol car and you're not using it very much, you're going to take a step change in environmental impact by buying a new electric car.
You're going to jump up your CO2 equivalent by a huge amount, which then will hopefully come over. There'll be an intercept point maybe 15 years later from just keeping your little Honda Jazz going from 2005.
And that's what you've got to think about, really. And it's the whole life cycle emissions. And it going back to manufacturing, the thing is about cars is that they're a very underutilized bit of kit, sitting outside people's house for most of the time. And it's that utilization of machinery and manufacturing that's good to think about as well, maximizing the use of the asset, because that will then reduce the life cycle emissions.
So you imagine the life cycle impact of a machine tool is mostly probably in the steel and the casting process. If you divide that by the number of parts it makes over its lifetime, the more parts you make, the less impact per part, and the more useful it is. So that's a really important idea. So don't throw away any of your old machines. People who are there with with an old EDM machine or a milling machine sat by the bay door, bring it back, get it working again.
Yeah, that's probably could be good advice. I mean, certainly go into it thinking of these issues. You know, what is the impact of a new system? And it can get very complex with life cycle assessment because there are lots of details. I mean, looking at where all the components come from, all these energy and waste flows, and also you've got to be defining your boundaries. And we talked, you mentioned the example of the bicycle earlier, and what did you have for breakfast when you got on your bike, and what's being burnt up to provide you with the energy to.
There's certain areas that it's just not even worth trying to dive into, is it?
You've got to draw the line somewhere because
because the whole world is so interconnected. Reality is so interconnected.
That's right.
With a life cycle assessment, and which is kind of the life cycle assessment is a really broad topic, and a small section of that is the greenhouse gas protocol, scope 1, 2, and 3 emissions. Yeah. But with life cycle assessment, you're basically trying to model the whole of reality. Yeah. Really, aren't you?
And
it's obviously impossible. So you have to draw a line somewhere and say, we're going to stop there, that resolution, that,
Well, the thing is, I suppose it's a characteristic of engineering in general. Nothing's 100%.
Yeah, you've got boundary conditions.
You have to draw a line, else you'd never get anything done, would you?
Yeah. I mean, no simulation, the whole point of any simulation, whether it be CFD or FEA or whatever, it's never correct. The whole point of simulation is just an approximation. Yeah. You have boundary conditions and assumptions. Yeah. And based on those, you try and get something that's close enough to reality to be useful. So the whole point of life cycle assessment is just like that. You need to set the right boundary conditions and assumptions that it's useful.
Yeah. That's right. That's the judgment you got to make with all this. What's an appropriate level of complexity?
Yeah. And that's the big thing. We've not even talked about the greenhouse gas protocol, EU legislation for companies over a certain turnover, and then how all of this stuff is useful for SMEs in manufacturing, who maybe should be looking at trying to measure their scope 1 and 2 emissions, and why should they? Why is that useful for them? We've talked a lot, and I think maybe we'd have to talk about greenhouse gas protocol a little bit later. But let's try a little bit. What is it? We talked about it in that talk that we met at. What is a greenhouse gas protocol? Who has to do it, and who should be doing it?
Well, greenhouse gas protocol is a framework for measuring and reporting on greenhouse gas emissions associated with operations of any kind, really.
Any business.
Yeah. And it categorises the emissions into scope 1, scope 2, and scope 3. I'll come back to that. But it's for any business, and it's a recognised framework, so it gives some uniformity. It allows the possibility of comparing different businesses, and for the benefit of stakeholders in the businesses, so they can judge environmental performance, because that can matter in terms of how the business fares in the market, because increasingly environmental performance is seen as being significant by investors and the public in general, who are the end customers. And the scopes 1, 2, and 3 are as follows. Scope 1 is direct emissions within the company's operations, and that includes the combustion of fossil fuels on site for heating, space heating, process heating. For example, natural gas, which is common, the gas boilers, and the gas used for them, for example. But it also includes the combustion of fuel in vehicles owned by the company. So basically, anything that is burnt by the company within its business is
on site or off site on one of their cars,
whatever it is that you own.
Yeah.
It's a scope.
Some companies might not be that much, really. They're just using CNC machines, for example. There you have electric combi boiler running radiators. Then you've not got. I guess the combi boiler actually is natural gas in it, but I guess for most companies, it might just be the natural gas in the boiler that gets burnt.
It might
and
be,
maybe company cars. So scope 1 can be quite small.
Yeah.
It's probably one of the easiest things to measure. I guess companies can use.
Yes, because you can. I mean, ideally you have metered data, so you can see how that consumption varies over the day and over the year. But otherwise, at least you can get an idea from billing data what's consumed over the course of the year.
So for the SMEs in machining that we might be talking about and kind of honing in on, scope 1's quite simple.
Yeah.
What's scope 2?
Scope 2 relates to the emissions from energy supply to the company, where the actual emissions are outside the boundaries of the company. So mainly that, for most companies, that relates to electricity supply, because the emissions associated with electricity, if it's not renewable electricity, will be from fossil fuel power stations, typically gas in part. I mean, the UK grid mix, a mixture of renewables, nuclear and fossil power generation. And those emissions are per kilowatt hour of electricity supplied. You can work out your kilowatt hours either from your metered data or again from the bills if you haven't got metered data, and multiply that by the emissions factor and you get your emissions for electricity. That's electricity, but scope 2 also applies to heating and coolth supplied via a district heating network. So if you've got chilled water or hot water being supplied to your site from an energy centre that is also supplying to other sites, it's owned and operated by another entity, but you're buying the energy from that energy centre. The emissions are taking place at the energy centre, so your consumption results in those emissions, but outside your business, that they're indirect. That's scope 2. Scope 3 are all the emissions in the whole value chain, indirect emissions, which upstream and downstream. So that relates to the whole supply chain, the emissions embodied in imported materials and components into the business.
And that's where it starts to get complicated.
Yeah, that is the most complicated, and it's also the most significant, because generally scope 3 emissions are around, over 90% of the overall emissions.
And that's really interesting, is that most of the impact I'm going to use CNC machine shop again as an example, most of the impact on the environment of your operations are not your operations, it's the use of the steel, the hardened steel material, the aluminium that you're buying in from a mill in Sweden or in Germany or in China. You're doing some transformative operation and you're shipping it back out, but it's mostly already happened. Most of the environmental impact.
Yeah, that's right.
Which is kind of, I guess, can make someone sleep a little bit better at night if they run a machine shop, because they know it's not their fault, kind of. But it kind of is.
Well, what they can do is reduce wastage potentially. You know, that's. I mean, I know that the thing is, a lot of ways businesses operate to save money are also good for the environment. I mean, a lot of businesses they'll be focused on reducing wastage because it saves them money anyway.
Exactly. So the scope 3, that material that comes in, I think if they looked a little bit about what is embodied in that material, you'd start to see a steel block as something much more precious than even just the monetary value. Yeah. The energy and effort that's gone into extracting it out of the ground, melting it together and making this beautiful square, perfect 200 mil square block that's now sat in front of you. I think that it gives it a bit of perspective as well, doesn't it?
Well, it does, and that's another reason for working with the whole company to get across to people what their role can be in making a difference in relation to reduction of emissions and environmental impact. Because if people have that awareness that you just referred to, then they might take greater care, not just to save money, but for other reasons.
Yeah, I think that's a very good point. And I think it's too much to start going into the data collection you need to do Scope 3 emissions reporting.
Well, the thing is, with data collection, Scope 3, you're reliant on other parties, and that's the difficulty. Because with the Scope 1 and Scope 2, you can measure it on site, and you're involved with that, Rowan, and you can make a difference there. But when you're an SME and you're reliant on getting data from often big companies, you haven't always got so much leverage. I mean, if you're a big supplier and you're going to an SME, you can put a lot of pressure on them. But if it's the other way around, it can be quite difficult. So you can try, but what I say is about Scope 3 is it's better to do something than nothing, and you've got to start somewhere. So it's a question of opening the dialogue with suppliers. You can send them questionnaires asking them about their emissions. They might ignore them at first.
And SMEs might be receiving those questionnaires as we speak.
Well, they are. Yeah, a lot of them are. That's
so there
right.
was something interesting in that talk. I can't remember the man's name, but he was talking about in a lot of yellow goods in aerospace, a lot of OEMs in the UK or tier 1 suppliers to the OEMs are asking their supply chain, not today, but next year, we will need some of this information from you. So Scope 3 might not be something that you have to do as an SME, but other companies might need to do their Scope 3, and that is all to do with what you do.
Yeah, that's right.
So that's really important.
It is important, and that changes the whole business driver, because in a lot of the work I've done in the past, helping companies evaluate options for energy improvements, thinking about sustainable energy measures, typically the options are being compared on the basis of life cycle cost benefit over a period of a few years. Whereas now, if you're not meeting the requirements of your suppliers, then you could be missing out on big contracts, and the value of those contracts you're missing out on could dwarf any potential energy savings. So that's another business driver. You've got to take into account the business opportunity and the disbenefit of the cost of not doing the reporting.
Definitely. So I think that's a really good point to end it on. Thank you so much, Rupert. It's engineering with a conscience, but also the business fits the business objectives of a lot of engineering companies out there. And if you're interested in renewable energy consulting, how to try and make your operations more sustainable, you can come talk to this man, Rupert Blackstone, Wattcraft. And also, if you're interested in the wider greenhouse gas protocol and ESG management of your own business, you're also working with Roger Singleton and Christine
Fair, yes.
Christine Fair at ESG3. So you guys are doing hands-on workshops. You have kind of quite a comprehensive package, but also a light package available for smaller companies that are wanting to dip their toe in and try and find out more about how to assess their own operations in this way.
Yeah, that's right. I mean, it makes it more accessible, more affordable, more streamlined. I mean, the ESG assessments are AI driven as well, which makes it more affordable. And really, a lot of this is about, it's good to know what your position is at the moment, to have a reality check, really. Even if you can't do everything straight away, at least you know what you're up against. And a lot of these measures we're talking about just make good business sense. You know, they're about being resilient for the future, being flexible, adaptable, all the things a business needs to be.
Yeah, exactly. So thank you so much, Rupert, for being another guest on the podcast, Data-Driven Manufacturing.
Pleasure, Rowan. Thank you for your time.
It's been fascinating, and I hope that listeners can think about engineering with a conscience a little bit more. And hopefully, maybe we can inspire a few people to be interested in this aspect of their jobs, because this applies to everybody around the world, in the UK, everyone in engineering, and every sector as well. So thank you so much, Rupert.